Now let's talk about TAILS. So what is TAILS? Well, it's an acronym that stands for Title, Axis, Interval, Label, and Scale. So it's going to help us remember that we need to have a title, we need to label our axes, we need to find an interval for our numbers, we need to make sure everything is labeled, and we need to scale. So making sure we have the appropriate scale. So let's talk about title. Well, we need to write the appropriate title for the graph at the top. So like for this one, what kind of pet do you own? Well, that's appropriate because it looks like they're looking at different types of pets, and they're looking at how many people have those different types of pets. So the title should contain both the independent and dependent variable. So talking about what kind of pet do you own, that's saying that they're going to survey a bunch of people and see what kind of pets they have. The next we're going to talk about is axes. So this is making sure that you're putting the right information on the right axes. So with this bar graph, they're putting the type of tree on the X and the number of trees on the Y. If you were to flip them backwards, it would be a sideways bar graph, and in this class, we will not create any of those. The independent variable is the type of tree, because you're changing the type of tree. You're saying, all right, we're going to talk about pecan, elm, sycamore, sweet gum, and pine trees, and that is it. Those are the only ones we are going to look at. Well, then the number of trees that you find are dependent upon the fact that you picked those 5 trees. So making sure you're putting the right information on the right axes is very important. Now let's talk about scale. So for scale, you need to decide on appropriate scale for each axis. So you need to choose a scale that lets you make the graph as large as possible for your paper and data. So you want to stretch it out as much as possible so that you can get a good picture of the data. You don't want it to look like this because we can't see the changes in that. You kind of want it to look like that, because then you can see the big changes instead of trying to use a magnifying glass to see that, oh, this went up and down at some point. Making sure you have the right scale helps you show your data in a better way. So how to determine scale? Well, scale is determined by your range of numbers, your highest number and your lowest number. And in the case of the data table on the right, our scale would be from 4 to 18. And using your range, you would decide on an appropriate scale for each axis. Your scale is going to refer to your minimum and maximum numbers used on each of the axes. So they may or may not start at 0. That ultimately depends on you and what you have decided. Let's say your first data point starts at 1,000. You could decide to start your graph off at 1,000. You could decide to go from 0 to 1,000 in one jump. You could decide to go from 0 to 1,000 in many jumps. Ultimately, the decision is yours, but making sure that your scale fits your range of numbers the best possible way. So how do we determine the intervals to go by for our scale? So the interval is decided by the scale that we have picked. So in the case of the data table on the right, our scale is from 4 to 18, and we want this to fit the graph. So you could subtract and divide by how many interval spaces you have. For the case of this data table, our best would be to go by 2s. Ultimately, again, the decision is yours, but generally you want to make your intervals so that you can stretch your graph out as far as possible within the space that you're given. So intervals is the amount of space between one number and the next, or one type of data and the next on the graph. You choose the interval that lets you make the graph as large as possible for your paper and data. So let's finally talk about the L in tails. We need to label our bars or data points, making sure that we know what everything is, where it is, and what the data means is very important. And labeling everything. You'll never hear me say this enough. Label, 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 label. Because we need to know the title. That helps us figure out what this graph is all about. You need to label your axes so that we know, oh, x-axis, well, that's dealing with the time, and the y-axis is dealing with how far somebody ran. Making sure that you're labeling your numbers so that we know that that person went 7 miles in 10 minutes. Unrealistic, but you know what I mean. Just making sure that we know everything so we can interpret the data correctly. So now let's talk about dry mix. So first we're going to talk about dry, and then we're going to talk about mix. So dry stands for dependent variable responding y-axis. So this is what you're measuring and what is expected to change. This is what you're looking at because of something that you have changed, and it's always going to go on the y-axis. Dependent variable, always on the y-axis. So now mix. This is manipulated independent variable x-axis. This is what you have changed. What you are changing, what you are affecting, is going right on the x-axis. So keep this in mind to help you remember to put what where. Dry, dependent variable responding y-axis, so your dependent variable is on your y-axis. Mix, manipulated independent variable x-axis. Your independent variable, what you are changing, goes on the x-axis. So now let's do some practice. Let's create a line graph with this data right here. So I have a piece of graph paper on here. If you don't have graph paper, that's fine. If you want to practice this with me, go ahead. If you want to pause the video and graph this on your own and then come back and see if you did it correctly, that's fine too. But we have been given distance and time. Remember, I have always said time goes on the x-axis because time is what you're controlling. You're the one who's affecting the time. You can make it go slower, or you can go slower, or you can go faster to make the time longer or shorter. So we're going to put time down here on the x-axis. Unfortunately, I don't have enough room, so I'm going to put it over here. Alright, and so then we also have distance. Distance, remember, this is what is being affected by the time. So that's going to go on my y-axis. So now, let's look at our ranges. Well, it looks like our lowest number for time is 1.5, and our highest is 12.9. So we have to come up with a scale that goes in between those two things. Okay, so let's go by ones. Well, that seemed to work. All right, so we have our scale for our x-axis. But now let's look at our y. So it looks like our lowest number is 10.3 and our highest is 90.6. Let's go by fives. Let's try that. Starting off at 10.3, or starting off at 10, let's jump by fives. So 10, 15, 20, 25, 30. All right, so it looks like that worked. So now let's graph this data. So if we have our first data point goes from 1.5 to 10.3. So 1 is right here. So halfway to 10.3, about there. All right, let's do the next one. 2.9 and 20.2. 2.9, 20.2, about there. 4.3 and 29.8. 4.3, 29.8. There we go. 5.8 and 40.4. All right, so I'm gonna finish graphing these real quick. You can follow my lead and do the same. So after you've graphed all that data, your line should look something like this. This is what your graph should look like. So if you were able to graph that, awesome. If not, again, you're gonna get more practice. So let's do a little bit of recap. We know that line graphs are for continuous data. Bar graphs are to compare data. Pie charts are used to show parts of a whole. We use tails to help label and determine the scale for graphs. And we use dry mix to help determine what we should put on which axes. So that wraps up the end of this lesson. If you have any questions, always write them down in your journals. Otherwise, if you feel it's fairly important and you need to know the answer right away, always send me an email or give me a text message and I will get back to you with the answer. Otherwise, have a great day.